So it would disappear that I have any deviations in my model. It shouldn't be. So that's why I should consider it as a 10, and here I should consider it as a 10. How to make it? That would be the first sensible way to do it. To take the, I think you mean the absolute value, yeah? Yeah, right? And the other way, what is also a mathematical approach in order to scale some value in order. Yeah, yeah, that's the answer. Why do we have a square or squares here? So we would take a square, being of course sure that by that we will have a positive here positive area or space, and of course a positive number. So for that kind of deviation we would have 100, and for that kind of deviation we would have also 100. So the sum would be 200 and not 0, 10 minus 10. Yeah? And the other reason for squares in comparison to your approach, which is also a sensible one, is that if you would consider, okay, how should we weigh this kind of deviations? I have, for example, here I have 10, and here I would have 2. Okay? So the idea behind it is to say, okay, if I would consider 2 with 10, sorry, minus, but we know we should take the absolute value, then I would have a difference of 8. And maybe this difference of 8 is not enough to stress that this strong deviation is a weak point of my model. Why that? Very, very, very easy. If a company would ask, what should I do in order to sell more? And I would say, I have a positive deviation, yeah, between your, for example, marketing costs and outcome, and I would say, okay, increase your costs by 1 million, and then you will sell more by 1,000 products. And then I'm wrong by 2 products. It's a good guess, yeah? But if I'm wrong by 500 products, it's not just a mistake by 498. It's a mistake which is more important. So that's why the idea is, okay, let's weigh this 10 much stronger than 2. And that's why if you calculate a square, it's clear that you have a larger difference between 100 and 4, right? Than between 10 and 2. So it would be the second reason why to use squares. And once again, the whole technique, you don't have to know it or to calculate it, but you have to know what's behind it. Is just to minimize the sum of the spaces of squares in our model in order to create the best prediction. Yeah, that's the whole story. And whether the prediction is for the purpose of a research question or a question for marketing, for a market, for example, it's actually the approach is the same. Yeah. So I remember an article about data collection and so on, and a journalist wondered that I guess it was in Munich in Garching they have their some research spot, yeah, and described it in this way, and what they do is they collect data, yeah, on, for example, on value of consumption for a single individual, and then having this whole data, they try to draw a line which is as close as possible to the whole observation, and then they can derive from that the prediction for the future. This kind of article, yeah. You're reading it and thinking, yeah, that's what we are doing now, yeah, and that's the simple model of a regression
in order to predict, to make some predictions. So please don't think it's a theory. Yeah, it's a little bit theoretical, but still it's very important for the modern world at the end. Yeah? Okay, but now if you don't have further questions, please make this small exercise. So now calculate your average tax rate for 2013 or any other year you have, and then calculate the deviation. So now calculate your average tax rate for 2013 or any other year you have, and then calculate the deviation between your tax rate in the country minus the average tax rate. And then run a regression, insert a chart in Excel. Yeah, it's not really running a regression, but at the end we have the same result. And then do the same in order to calculate your equation for FDI versus the difference between tax rate and average tax rate. It's clear? So in your table, in your data set, calculate the average tax rate, taking countries are in your regressions now, okay? So average tax rate, and then using your tax rate for a particular country, minus average, calculate just the difference between the tax rate and the average. And then run a regression using FDI and the difference between tax rate and average. Okay? You have to move somehow your columns, or just do copy paste, because Excel, that's the shortcoming of Excel. You should have two columns as a Y and X. Yeah, you can't, as far as I know, it's not possible just to pick up columns you would like to use. Okay, so they have to stick to each other. That's a little bit the weakness of Excel sheets.
So we are taking table without outline.
No, I mean if you insert your chart and then try again with trend line and so on, you have two columns that stick to each other. So that's why I would just copy this 1 year, yeah, and then calculate this difference between average tax rate and tax rate. Okay. Usually important. Usually, this interpretation of the framework doesn't make any sense. But in this case, it makes sense because it's possible that we have a country with a tax rate of 0. If you would, for example, I don't know, take wage of a table, and I would check whether the size of the table, yeah, has some correlation with the weight. I guess it will be the case. However, we will have, once again, not R squared at the level of 100%, because it could be a wood table. I could have some observations on other tables. You know, so I would have some other variables are responsible in order to explain the weight of the table. But in this case, it wouldn't make any sense to interpret this intercept, yeah? Because it would mean if my table doesn't have a size, or has a size of 0, so what kind of table is that? Yeah? Then the weight would be 40 kilograms. Yeah? So please be careful. Do not try to interpret every interception. But in this case, it makes sense. So in a tax rate of 0, we would have FDI of 83% of GDP. Great. Now let's stick to this exercise, to this result, which is a little bit different regarding the intercept. So, what is here the interpretation once again?
The tax rate is 0.
Then?
The FDI is 44.94% of the GDP.
It's possible. Firstly, we considered, or our statement was like, if tax rate is 0, then